Okay, this is the P3 paper from January 2024. It's question number 9, and this is a trig addition formulae question. We're going to be doing some work using double angle and some work using simplifying a cos x plus b sin x. Let's have a look at part A then. Part A says, can we show that this equation can be rewritten into this format here? So when we're doing one of these questions, what my students often say to me is, I don't know how to get started, sir. So what we've got to look at is what we're trying to end up with. We're trying to end up with sine 2 theta and cos 2 theta. And I'm not going to write this down and keep it written down, but we should know what these two identities are then. Sine 2 theta is 2 sine theta cos theta. Well, look over here, and we've got sine theta cos theta. I can make an adaptation for the constant there, so that's where my sine 2 theta is going to come from. And what about cos 2 theta? Well, cos 2 theta is cos squared theta minus sine squared theta. It is also 2 cos squared minus 1 and 1 minus 2 sine squared, but I don't need either of those two this time. If it's cos squared minus sine squared, and this is quite difficult, but what you've got to see here is if I've got cos x plus sine x there and cos x minus sine x there, my normal first step I would have thought would have been to multiply that up, and if I do multiply that up, a plus b, a minus b works out to be a squared minus b squared. So I've got a really good idea about how to get started with this question now, simply by having a quick look at it first and then saying, well, I've got some steps that I can take first of all. So I'm going to get rid of this bit here. It's not part of my answer necessarily. And I'm going to say, let's write down the start off point, which was 3 sine theta cos theta, all divided by cos theta plus sine theta is equal to 2 plus sec 2 theta. I've not really looked at that part of it yet, but we'll get there when we come to it. So here, my first step is going to be just to multiply up. So if I multiply up, I'm going to get 3 sine theta cos theta is equal to 2 plus sec 2 theta, and then cos theta plus sine theta times cos theta minus sine theta. You can take longer if you want, but I'm going to go straight away with writing that down like that. Now I'm going to look at both the double angle formula at the same time. This sine theta cos theta, I'm going to say that's half of 2 sine theta cos theta. So here the half and the 2 would cancel each other out, but the reason I've put them on is because with my next line I'll actually say, well, that's sine 2 theta. So on the left hand side I've done something, and then on the right hand side all I'm going to do is say, yeah, that's cos 2 theta there. So now on the left hand side 3 times a half is 3 over 2, and this bit in brackets is sine 2 theta. And on the right hand side I'm going to multiply it out. I'm going to get 2 cos 2 theta. Now you can write sec 2 theta cos 2 theta if you want, but sec 2 theta is 1 over cos 2 theta. So actually that's just going to cancel out to be equal to 1 there. Now let's multiply everything by 2. You might at this stage want to have a look at what we're trying to get to here, because we're very close to it. So 2 cos 2 theta plus 1. If you look at what we're actually trying to get it to be, that it's just a matter of multiplying everything out now. So 3 sine 2 theta is equal to 4 cos 2 theta plus 2. And so then just put it in the right way round. 3 sine 2 theta minus 4 cos 2 theta is equal to 2. And that's what we were actually trying to prove for part A. So fantastic. On to part B. It says, hence solve for that range of values. I'll talk about that a little bit later on, but just be aware of that when we come back to it at the very end. Our answers are going to be quite strange, actually, between pi and 3 pi over 2, but yeah, we'll get there when we need to with that one. It says solve this equation, and solving this equation is really solving that equation there, isn't it? So I'm going to write that out as my equation for part B and then see if we can solve it. So part B, our equation is solve 3 sine 2x minus 4 cos 2x equals 2. Now, if this was equal to 0 here, I could swap the sine and the cos over, get tan 2x. We could solve it really, really quickly. But as soon as it's not that, then I have to use all the work with the a cos x plus or minus b sine x. We're going to be using that part of the trig identities, trig addition formulae. So what we're looking at is we're saying, how do we do those ones? Right, so I'm just going to focus on the left-hand side, and I'm going to say, right, 3 sine 2x minus 4 cos 2x. Now, sometimes they actually tell me which one of these to use. If they don't tell me which one to use, in terms of here, this is sine A minus B. I could have sine A minus B, cos A minus B, sine A plus B, cos A plus B. If they don't tell us which one, then I've got to look at whichever of the identities gives me a sine minus a cos. And our sine A minus B does give me that situation. You'll see it with the next line. So we're going to say, yep, so 3 sine 2x minus 4 cos 2x then works out to be sine of A minus B is sine A cos B minus cos A sine B, but I'm going to write it out anyway. So that's R sine 2x cos alpha minus R cos 2x sine alpha. And the key is that I chose on where that was a negative in there, so we can just really easily now say whatever I'm multiplying by sine 2x on this side is the same as what I'm multiplying by sine 2x on this side. You should have done lots of these. We always end up with very similar from this point on. R is going to be equal to 3 is going to be equal to R cos alpha, and 4 is going to be equal to R sine alpha. At this stage, we always have pretty much R cos alpha, R sine alpha is equal to something, because what I'm then going to do with these two, I'll still tell you what I'm going to do, but you should absolutely know at this stage, if I divide 2 divided by 1, I'll get tan alpha. So let's tell the examiner I'm doing that. 2 divided by 1 gives me tan alpha, because the R's go and I get sine over cos. Tan alpha is equal to 4 over 3. So that means I can work out what alpha is. We're doing it in radians. I'm going to do it to 3 decimal places. It works out to be 0.927 radians. And then when we want to work out R for this, it's always just the square root of this squared plus this squared. So the square root of 3 squared plus 4 squared. Sometimes it does work out to be equal to a third. In this case, it's working out to be equal to 5. So what I can now do is I can now look at this statement here and put in the value R and put in the value alpha. So 3 sine 2x minus 4 cos 2x is the same as 5 sine 2x minus 0.927. So now if I'm trying to solve the equation, I'm going to say 5 sine 2x minus 0.927 is equal to 2. From here on in, it's relatively straightforward. You just need to be aware of that range of values, remember, as we were going through. So if I've got that, I get that sine 2x minus 0.927 is equal to 2/5. And so 2x minus 0.927 is going to be a range of values here. I'll tell you what they are and then we'll talk about where they come from. It's going to be 0.412, it's going to be 2.730, it's going to be 6.695. Let's quickly tell where they came from. So remember, if sine worked out to be equal to 2/5, this acute angle worked out to be 0.41. And where is sine positive? Here and here. So my answers are going to be 0.41, pi minus 0.41. Those are two of them. We can keep going, can't we? Obviously, we could have all the way round there and have 2 pi added on to that, we can go all the way around there and have 2 pi added onto that. That's where this value comes in. And the only reason I've stopped there is obviously I've done this in advance. At this stage now, let's get rid of that, we've got that 2x minus 0.927 is equal to those ones. So if I want to work out what x is equal to, I'm going to add 0.927 onto that and then divide by 2 for all 3 of these values. And what we get from these when we do that is 0.6695, I don't know, 4 decimal places, doesn't really matter, does it? 1.8285 and 3.811 once we've done the rearranging, and that one there, the 3.811, is the only value that sits in between that range. Oh, we want it to 3 significant figures. Okay, so I'll answer it properly. So x is equal to 3.81 then, to 3 significant figures. Okay, if that last part didn't make much sense to you, then go back and look at some of my previous videos where I spent a little bit more time looking at simple trig equations. But yeah, that's the question number 9, end of that paper. Hopefully that all makes sense to everybody.